Good morning students, welcome to our channel Easy Chem. Today we are going to discuss about carbon and its compounds. Today we are going to discuss about carbon and its compounds. This is the very important lesson in your 10th class. Okay, now first, what is the symbol of carbon? The symbol of carbon is C. What is its atomic number? Its atomic number is 6. Okay, so now my question is, what is atomic number? The atomic number means atomic number. Atomic number means the number of protons present in the nucleus. Number of protons present in the nucleus is called as a atomic number. Okay, for example, if you consider a neutral atom, not only carbon, if you consider one neutral atom, okay, in any neutral atom, what happens? For example, if a atom is neutral, means then the number of positive charges is equal to the number of negative charges, isn't it? What are the positively charged particles in the atom? Protons are the positively charged particles in the atom. What are the negatively charged particles in atom? Electrons are the negatively charged particles in the atom. So in neutral atom, what I am saying, the number of positive charges is equal to the number of negative charges, isn't it? So therefore the number of protons is equal to the number of protons is equal to number of electrons. Number of protons is equal to number of electrons in a neutral atom. Okay, this is true only for the neutral atoms. Okay, this statement, this number of protons is equal to the number of electrons in the neutral atom. Then what about ions? How many types of ions are there? Generally there are two types of ions. What are those ions? The first ion is a cations. Now let us discuss about ions. What are those ions? The one ion is a cation, other ion is a anion. What are those? Cation and anion, isn't it? Okay, what is cation? First see, cation. Cations, C-A-T-I-O-N, cation. The positively charged ion is called the cation. The negatively charged ion is called the anion, isn't it? The positively charged ion is called the cation. The negatively charged ion is called as a anion. Okay. For example, if we want to form a cation from the neutral atom, that means, for example, consider here we are discussing about carbon and its compound. So I am taking the example of carbon here. What is the atomic number of carbon? 6. Can you write the electronic configuration of carbon? Yes, we can write it. How it is? 1s2, 2s2, 2p2, 2 plus 2 4, 4 plus 2 6. How many electrons are there? 6 electrons, 6 protons and 6 electrons present in the carbon. Okay, this is the electronic configuration of carbon. For example, if not only for example, consider an atom A. Okay, consider a neutral atom A. Okay, if I am adding electrons to this neutral atom, it will becomes as a, what I am adding here, I am adding negative charge to the neutral atom. That means I am adding electrons to the neutral atom. It becomes A minus. That means anion. Okay, if I add two electrons to the neutral atom, then what happens? It becomes A2 minus. If I add n electrons to the neutral atom, it becomes An minus, isn't it? These are all anions. The only difference is the magnitude of charge. Here the charge is -1, here -2, here -n. If I add an electron to the neutral atom, then it forms anion. Electron ni add చేస్తే ఏం ఫామ్ అవుతున్నాయి మనకి anions ఫామ్ అవుతున్నాయి. ఓకేనా. Next, if I remove an electron from the neutral atom, for example, A is a neutral atom. From this neutral atom, here I am removing an electron. Then what happens? It forms A plus. What is this? The plus charge means it is a cation. Okay, if I remove 2 electrons from neutral atom, then then it forms A plus 2. If I remove n electrons, means it forms A n plus, isn't it? So these are all cations. The cations are formed by the removing of electrons, and anions are formed by the adding of electron to the neutral atom. Okay, this way the cations and anions are formed. Now let us see the cation and anion formation in the carbon. Okay, if you observe the periodic table, in the group 8 in the periodic table, in group 18 elements, what are the elements in the group 18 in the periodic table? Helium, neon, argon, krypton, xenon and radon. These are the elements present in the 18th group of the periodic table. Okay, what is the general electronic configuration of 18th group? The general electronic configuration of 18th group is NH2 NP6. There is one exception here. What is that? Helium. Helium contains only 2 electrons, that is the configuration is 1s2. Remaining all inert gas elements contains the general configuration NH2 NP6. For example, if you see the neon, then what happens? 1s2, 2s2, 2p6. Okay, from here I am writing only outermost electronic configurations. Okay, that means here it becomes 3s2, 3p6, 4s2, 4p6 and so on, 5s2, 5p6, 6s2, 6p6. Okay, now your question is, what is the outermost shell? What is the valence shell? Both are one and the same. The outermost shell means for example, consider this is a carbon atom. Okay, this is the first shell and this is the second shell. 1s2, the configuration of carbon 1s2, 2s2, 2p2. This is the first shell, this is the second shell. The first shell contains s orbital, the second shell contains s and p orbitals. Okay, so what is the last shell in the carbon here? The second shell. So if the second shell becomes the valency shell of the carbon, isn't it? For neon also, the second shell is the valency shell. For argon, the third shell is the valency shell. The valency shell means the outermost orbit or the outermost shell is called the valency shell. Outermost shell or valency shell. Okay, if you observe these inert gas, except helium, if you observe these inert gas elements, they contain how many electrons? 2 plus 6, 8 electrons. 2 plus 6, 8 electrons. 2 plus 6, 8 electrons. These also. Okay, except helium, all inert gas elements contains 8 electrons in their valency shell or outermost shell. Except helium, all other inert gas elements contains 8 electrons in their valency shell. This is so called octet configuration. Octet configuration. Because of this octet configuration, these inert gas elements are inert towards the reactions. Why inert gas elements are inert or noble inert towards the reactions? That means why they do not involve in the reactions means because of the octet configuration in their valency shell. So because of the octet configuration, these are noble gases become stable. Okay, except helium, but helium also stable because it is also a noble gas. All noble gases are stable. Okay, every element, not only carbon, every element tries to attain noble gas configuration. Why? Every element or every atom tries to get in stability. Okay, every atom tries to attain stability. To get stability, it needs how many electrons? 8 electrons. Every atom, if for example carbon gets 8 electron in its valency shell, means it becomes stable. Like not only carbon, every element tries to attain octet configuration for stability. Every element tries to acquire the octet configuration to get stability. Okay, for example, here I am talking about, here we are discussing about the carbon. The atomic number is 6. The configuration is 1s2, 2s2, 2p2, isn't it? Okay, the valency shell of carbon is 2s2, 2p. Second shell is the valency shell. The second shell contains how many electrons here? 2 plus 2. 2 plus 2 is equal to how many electrons? 4 electrons. Okay. To get octet configuration, the carbon needs how many electrons? 4 electrons, isn't it? It has the 4 electrons. To get 8 electrons in the valency shell, it needs 4 electrons. Okay. Carbon. The configuration is 1s2, 2s2, 2p2. Okay. If the carbon gains 4 electrons, then what? Then it forms which ion? The carbon. Carbon here gaining electrons. The carbon gaining electrons here. So it forms anion. Which anion? Anion. What is the charge? What the magnitude of charge on this carbon? It acquires 4 electrons, so it forms 4 minus ion, isn't it? What is the electronic configuration of 4 minus? 1s2, 2s2, 2p6. Okay. If carbon acquire 4 electrons, then it becomes C4 minus. The C4 minus configuration is 1s2, 2s2, 2p6. Here see in the C4 minus, the outermost shell contains how many electrons? 2 plus 6, that is equal to 8. It attains the octet configuration, so it becomes stable, isn't it? Yes. But okay, here how many number of electrons are there in C4 minus? I am not asking about the valency electrons. I am asking about how many electrons are present in the this C4 minus ion. How many electrons? 2 plus 2, 4. 4 plus 6, 10. Total in C4 minus there are 10 electrons, isn't it? But how many protons are there? Here we are adding only electrons, but the protons remain same. What is the atomic number of carbon? 6. So the C4 minus contains the C4 minus ion. The C4 minus ion contains how many protons? 6 protons and how many electrons? 10 electrons. Okay, the C4 minus ion contains 6 protons and 10 electrons, but it is very difficult to hold the nucleus which contains 6 electrons. That means what I am saying is it is very difficult to hold 10 electrons. Okay, the nucleus of the carbon contains 6 protons and it has to hold the 10 electrons in C4 minus. It is very difficult for the nucleus which is having 6 protons to hold 10 electrons. So the formation of C4 minus is not easy. Okay, the formation of C4 minus is not easy. So next. For example, again carbon, the configuration is 1s2, 2s2, 2p2, isn't it? This is the configuration of carbon. If the carbon loses 4 electrons, then what happens? It forms cation. Which cation? C4 plus cation. If it loses 4 electrons means the configuration is 1s2, 2s0, 2p0. Okay. 1s2. The configuration is 1s2. The 1s2 is the configuration of helium. So, if it forms C4 plus, the configuration becomes 1s2. and it is the helium configuration, so it becomes stable. But here the problem is, we know, for example, this is the carbon atom, this is a 2s orbital and this is the 2p orbital. Now we have to remove how many electrons? 4 electrons. The energy required to remove an electron from the outermost orbit. The energy required to remove an electron from the outermost orbit is called as a ionization energy. So we require energy. So we have to remove one electron, we require some amount of energy. To require second electron, we need more amount of energy because the nuclear attractions increases. Okay, the nuclear attractions, as we removing the electrons, what happens? The nuclear attractions increases, so that we need a very large amount of energy. We need very large amount of energy. Large amount of energy to remove, we need very large amount of energy to remove 4 electrons. So the formation of C4 plus is also not easy. So carbon cannot easily form the C4 minus ion. Carbon cannot form either C4 minus or C4 plus easily. So then how the carbon attains octet configuration? It is not easy to form C4 minus ion and it is not easy to form C4 plus ion. Then how carbon attains its octet configuration and gets stability? Yes, here the question. Okay, the carbon by sharing of electrons, carbon by sharing of electrons gets the octet configuration. Okay, by sharing of electrons, carbon get the octet configuration. The bond which is formed by the sharing of electrons is known as what? Covalent bond. The bond which is formed by the sharing of electrons is known as which bond? Is known as a covalent bond. Okay. So the carbon can, okay, now let us see. Here the configuration is 1s2, 2s2, 2p2. It needs how many electrons to get octet configuration? It needs 4 electrons. So the carbon form how many covalent bonds? 4 covalent bonds. Because it needs 4 electrons, it shares the 4 electrons with other atoms and it attains octet configuration. Okay. For example, if you see here, the configuration of carbon is 1s2, 2s2, 2p2. In the outermost shell, it has the 4 electrons. So the carbon do not form C4 minus and C4 plus normally. So to attain octet, it will attain octet by sharing of electrons. The bond which is formed by the sharing of electrons is called the, what is that? Covalent bond. Okay. So the carbon can form how many covalent bonds? It needs 4 electrons, so it forms 4 covalent bonds. The carbon can form 4 covalent bonds. So the carbon can form how many covalent bonds? The carbon can form 4 covalent bonds. Okay. The number of covalent bonds is called as what? Covalency. The number of covalent bonds is called covalency. Now tell me, what is the covalency or valency of carbon? What is the carbon can form how many covalent bonds? 4 covalent bonds. The number of covalent bonds is called what? Covalency. The number of covalent bonds is called covalency. Therefore, the covalency or valency of carbon is the covalency of carbon. The covalency of carbon is 4. What is the covalency of carbon? It is 4. In almost all of its compounds, in all its compounds, the carbon exhibits the covalency 4. That means it can form the 4 covalent bonds. In all of its compounds, the carbon form 4 covalent bonds. Okay. There are how many types of covalent bonds? Covalent bonds are The covalent bonds are single covalent bond. The types of covalent bonds: single covalent bond, double covalent bond, and triple covalent bond. The single covalent bond is represented by the one horizontal line. The double covalent bond is represented by the two horizontal lines. The triple covalent bond is represented by the three horizontal lines. What is the covalency of carbon? The covalency of carbon is what? 4. The covalent, that means the carbon can form 4 covalent bonds. Okay na? The carbon can form 4 covalent bonds. Okay. These are either single bonds or double bonds or triple bonds. Any covalent bonds, but the carbon can form how many covalent bonds? 4 covalent bonds. Okay. How the single bond is formed by the sideways overlap of the orbitals. That means it is a sigma bond. Okay. In double bond there is one sigma bond and one pi bond. In triple bond there is one sigma bond and two pi bonds. These topics you can study it in the chemical bonding chapter. How the single bond is formed, how the double bond is formed, how the triple bond is formed. In a single bond there is only sigma bond. In double bond there is one sigma bond and one pi bond. In triple bond there is one sigma bond and two pi bonds. The sigma bonds are formed by end-on and overlap of the orbitals. The pi bonds are formed by the sideways overlap of the orbitals. Okay. The sigma bonds are formed by the end-on and overlap of orbitals. The double bonds, the pi bonds are formed by the sideways overlapping of orbitals. Now what I am saying is the covalency of carbon is 4. Okay. That means it has to form 4 covalent bonds. It satisfies covalency 4 either by forming 4 single covalent bonds. 4 single covalent bonds. 4 single covalent bonds. Then example. This is a carbon. 1, 2, 3. What is the covalence of carbon? 4. It forms how many covalent bonds? 1, 2, 3, 4. For example, I am writing hydrogen. That means the carbon forms the covalent bonds with the hydrogen. So the carbon forms how many bonds here? 1, 2, 3, 4. So the covalence of the carbon is the carbon form 4 covalent bonds so that it gets the octet configuration, because here one electron and in a single bond there is how many electrons? 2 electrons. In a single bond there are 2 electrons. Here how many electrons? 1, 2 electrons. Here 1, 2 electrons in this single bond. 1, 2 this and 2 electrons in this single bond. So this shared pair of electron belongs to this carbon and also this hydrogen. So count the number of electrons around the carbon. 1, 2, 3, 4, 5, 6, 7, 8. How many electrons are there in the carbon? Here 8 electrons. That means the carbon gets the octet configuration by sharing of electrons through single bonds. Okay. Carbon can form 4 single covalent bonds. For example, there is a single bond present between carbon and carbon. These type of compounds are called as alkanes. In alkanes only single bonds are present in the alkanes. Now let us see the other possibilities. Okay. The carbon can form 4 single covalent bonds, or it can form 1 double bond and 2 single bonds. I will explain this with an example. For example, this is a carbon. This is another carbon. Here I am placing other bond. This is a double bond. 1, 2, 1, 2. Here I am placing hydrogen. Here hydrogen, hydrogen and hydrogen. Let us consider this carbon. Okay, this carbon. How many bonds are there here? 1, 2, 3, 4. Here the carbon forms how many covalent bonds? 4 covalent bonds, isn't it? Okay, here the carbon forms 1, 2, 3, 4 covalent bonds. Out of these 4 covalent bonds, one is a double covalent bond and 2 are single covalent bonds. Okay, the carbon either can form 4 single bonds or it can form 1 double bond and 2 single bonds. So the compounds which contain C double bond C, these are called as a alkenes. What these are called as a alkenes. I will tell these the names of these compounds in the nomenclature. Okay, the compounds which contain C double bond C, these are called as alkenes. Okay, next, what is the other possibility? Now the other possibility is the carbon can form 1 triple bond and 1 single bond. I will explain this also with an example. For example, carbon, triple bond, carbon, here 1 hydrogen, here 1 hydrogen. Okay, consider this carbon. How many bonds are there? 1, 2, 3, 4 bonds. Around the carbon there are 4 bonds. This carbon satisfies the covalency 4. So the number of covalent bonds around this carbon is 1, 2, 3, 4. Okay, now then out of these 4 covalent bonds, one is a triple covalent bond and one is a single covalent bond. The compounds which contain C triple bond C are called as alkynes. The compounds which contains C single bond C are called as alkanes. The compounds which contain C double bond C are called as alkenes. The compounds which contain C triple bond C are called as alkynes. The next one, there is another possibility. The carbon can form 2 double bonds. See here. Here is a 1 carbon. Consider this carbon. How many bonds are around this carbon? 1, 2, 3, 4. So these 2 are double bonds, isn't it? So here the carbon forms 4 bonds and the 4 covalent bonds, and these are double bonds. Okay, so the carbon can form 4 single covalent bonds or 1 double bond and 2 single bonds, or 1 triple bond and 1 single bond or 2 double bonds. The compounds which contains 2 double bonds are called as di. 2 means di, double bond means ene, dienes. The compounds which contains 2 double bonds. Double bond means double bond means we are calling it as a ene, isn't it? Here how many double bonds are there? 1, 2. So we call these compounds as a dienes. Okay, this is the way the carbon can form 4 covalent bonds with its own atoms or with other atoms. Now my question is, consider carbon. Its atomic number is 6. Electronic configuration is 1s2, 2s2, 2p2. What is the n plus L value for this orbital? N plus L value. What is the n plus L value for 2p orbital? The n plus L value for 2s orbital. What is the n value here? 2. What is the L value for s orbital? L value for s orbital is 0. You know that for s orbital L values 0, 1, 2, 3. If L value is 0, it is in s orbital. If L value is 1, it is a p orbital. 2, that means it is a d orbital. Okay, like this. So it is a s orbital. So for s orbital the L value is 0. For s orbital the L value is 0. 2 plus 0 means 2. Next, what is the n plus L value of this 2p orbital? The n value is 2. What is the L value? The L value for p orbital is 1. 2 plus 1 is equal to 3. N plus L value increases. Energy also increases. Now tell me which orbital having the more amount of energy? Obviously the 2p orbital have the more amount of energy compared to the 2s orbital. That means there is a difference in energies between the 2s and 2p orbitals. Okay, I am writing like this. This is a 2s orbital and this is a 2p orbital. It is the energy increasing order. The 2p orbital has the more energy compared to the 2s orbital. Okay, the 2p orbitals contains 2 electrons. Here 1 and 2. Total how many electrons? 1, 2, 3, 4 electrons. Okay, normally in ground state, that means whenever the carbon is free, if the carbon is free, the carbon exists in the ground state. That means its configuration is 1s2. I will write over here. Whenever the carbon is in the free state, what is its electronic configuration? 1s2, 2s2, 2p2. Whenever the carbon is free, then it is in the which state? Ground state. Okay, this is called the ground state. For example, if I supply some energy to the electron in the 2s orbital, there is an energy difference between 2s and 2p orbital, isn't it? The 2s orbital, there is energy difference between 2s and 2p orbital. Okay, if I so it is having the low amount of energy, it is having the higher amount of energy. If I supply energy to the electron in the s orbital, then what happens? It jumps from here to here. That means the configuration becomes 2s1, 2p3. Here 1 electron, here 3 electron. In the ground state, how many unpaired electrons are there in the unpaired electrons? Means there is no pairing. These are the unpaired electrons. Okay, in ground state, the number of unpaired electrons in the carbon are 2, isn't it? In the excited, this is called the excited state. Why it is called the excited state? Here we are supplying the energy so that the electron in the lower energy level excited to the higher energy level. So it is called as a excited state. Okay, so in the excited state, there are how many unpaired electrons are there? In the excited state, there are 1, 2, 3, 4. 4 unpaired electrons are there in the excited state of the carbon. Okay, now my question is, we need energy to excite an electron from 2s to 2p. Okay, where this energy to excite electron comes from? Where this energy to excite electron comes from? ఈ ఎనర్జీ మనకి ఎక్కడి నుంచి వస్తుంది? Okay, I will explain this. Whenever the carbon is free, it exists in the ground state. Okay, when the carbon is ready to form bonds, before that I will explain one thing. For example, this is a carbon. Consider it can form. There is a bond between the carbon and hydrogen. Okay, if I want to break the bond, what I have to do? I have to supply energy, isn't it? There is a attraction, there is a bond between carbon and hydrogen. To break the bond, I have to supply energy. That means to break the bond, I have to supply energy. Okay, if the hydrogen forms bond with carbon, that means in the formation of bond, there is a release of energy, isn't it? In the bond formation, there is a release of energy, and in bond breaking, we need energy. Remember these points. Note. What is the note? To break bond. Other way, to break bond, we need what? We need energy. Okay, during bond formation, energy energy is released. Okay, energy is released. To break the bond, we need energy. In the formation of bond, the energy is released in the formation or during the formation of bond. Whenever the carbon ready to form bonds with certain other atoms, for example, I am considering here the hydrogen. Whenever the carbon is ready to form bonds with other atoms, then what happens? There is a release of bond energy. There is a release of bond energy, isn't it? Here the bond is forming, so there is a release of bond energy, isn't it? Here between the carbon and hydrogen the bond is forming, so that the bond energy is released here. This bond energy is used to excite electron from 2s to 2p orbitals. This is the answer to this question, where this energy to excite electrons comes from. ఎక్కడి నుంచి వస్తుందంటే ఎనర్జీ మనకి whenever the carbon is free, so it is exist in the ground state only. Whenever the carbon forms bond with other atoms, then there is a release of bond energies. Whenever the carbon forms bonds, then there is a release of bond energy. This bond energy is used to excite electron from 2s to 2p. Not only 2, I am discussing about here carbon, so I am here saying 2s to 2p. Okay, whenever the carbon forms bond with hydrogen or any other element, any other atom or element, then what happens? There is a release of bond energy. This energy is used to excite electron from lower level to the higher level. This is about the introduction regarding the carbon and its compounds. Next class we will going to discuss about the hybridization. Okay students, thank you for watching. Please do subscribe to our channel.